Can you see my screen?
Yes, everything works fine from my end. I believe we're good.
Okay, so we can start.
Yes, of course.
Okay, so hello to everybody. I'm Antonio Filograna from Engineering Informatica, and I'm the project manager as senior researcher. Engineering Informatica is the biggest digital transformation company in Italy, and we are leader in Italy, and we are expanding our footprint across all the Europe and all the world with around 70 offices in 16 countries. So the group I belong to is focused on the innovation through our research and innovation division that comprise more or less 450 researchers and data scientists. Our research is focused mainly on innovation from public administration and digital experience, in particular on the adoption of the disruptive technology in different fields and domains, such as social innovation, smart cities, smart government, and of course in natural disasters management. And we have expertise in several technologies, in particular in data protection and preserving technology, big data analytics and visualization, cloud infrastructure and services, open data management, and system integration and interoperability. So today I would like to give you an overall view, a transversal view about how the data storytelling and big data value chain analytics can support the natural disaster management, and how these two topics are correlated. So, starting from some times ago, some of you knows who is this lady? Just to give a brief introduction, starting from the history of the data storytelling and the big data analytics. So she's Florence Nightingale, and she lived in the 19th century. She was a nurse during the Crimean War in 1856. Why I'm talking about her? Because in that period, she came back from the Crimean War, and after nurturing a lot of soldiers and being responsible of the most of the different UK infirmaries in the camps, she understood that starting from her experience, that the main causes of mortality in the ranks of the army were due not only to the bullets, to fighting with the enemy, or to the cannons, but also to the healthcare condition in which soldiers lived. And she collected a lot of data, analyzed them with the support of scientists and the statisticians, and the result of her analysis demonstrated that one of the most important factors of the death of the soldier was and in particular among the hospitalized patients, was the overcrowding of the hospital. And starting from this result, Florence Nightingale proposed some solution to improve the quality of life of the soldier, and in particular a huge healthcare reform based on three factors: the sewerage network reclamation, the clean air in the rooms, and the reduction of overcrowding. And she might present this data to the decision maker, and her objective was the chief of the British Army, that was the Queen Victoria. And to catch the attention by this decision maker and to talk the same language of them, Florence Nightingale could not present the raw data as they were, but she adopted, as you can see, a fascinating, for this period, of course, approach to introduce the information coming from the data they collected and analyzed. So she used these end draw diagrams never seen before, going beyond the visualization of the graph themselves and getting a real data storytelling. What happened after this demonstration of the parliament and the decision maker and the Queen Victoria? So the parliament adopted what she proposed, and the result confirmed what she demonstrated with her information. And this reform was included in the British Public Act in the 1875 that had a huge impact not only for the soldier and their condition, but for the citizen healthcare condition. So we can say that Florence Nightingale was the first data storytelling by using a lot of data and a new way of visualizing data for providing information and not raw data, because sometimes we think that we have a lot of raw data, but raw data are useful only for the data scientist. What we need to provide to the policy maker, to the decision maker, to public, is the information, and the information is the data analysis and the visualization of the data. And coming to the second topic of this discussion is the big data. And big data is a new keyword. So in the last, let me say, 10 years, we talk about big data, but who manage big data for the first time? For sure, in the domain of particle physics. So the physicists start to collect data through the cloud chamber, that is a particle detector using for visualizing the passage of the ionizing radiation. And during the years, so one century ago, and going in the history of the particle physics, we have the first standard linear accelerator at Stanford University that reach an energy of 50 gigaelectron volt and collect 100 terabyte per year. And in the end, we will have the LHC, so the Large Hadron Collider, that collect more or less 1-2 petabyte per day in 2012, when the Higgs boson was discovered. And here we can see the difference between and how the data collected increases during the year. So we have at the beginning of the 20, so the end of the last century and the beginning of the new century, we have in the slack collect 300 terabytes per year. And here at the CERN in Geneva, here we can see that starting from more or less 13 years ago, the CERN collect 1 petabyte per years, and now we are at 1 exabyte per year in 2023. But what is the difference between the past big data? No, we talk about the particle physics and the new big data. Nowadays, the big data are heterogeneous, and while the particle physics, the data was related only to the domain of the physics. And today, the big data coming from different data sources and different domain. And we can, with this data, with this raw data coming from different domain, for example, communication, medical, industry, vehicles, and so on, we can extract information that could add an added value to an added value coming from data of different domains. And for example, now I'll give you an example of the big data analysis in several domains. For example, in healthcare, the level of data generated within the healthcare system is not trivial for sure. And the healthcare industries largely use big data for several reasons, in particular for the limited ability to standardize and consolidate data. And this was one of the most important issue, the standardization of the data, in order to collect and harmonize the data. But now, with the advent of the big data analytics, the big data analytics have improved the healthcare by providing, for example, personalized medicine with the bioengineering and perspective analytics. And researchers are mining the data to see what treatment are more efficient for particular condition, so identifying some parts related to the effect of the drugs, or gain important information to the patient and reduce the cost. We can think about the experience of big data in the COVID-19, in the pandemic. We had in the few years ago. And with the adoption also of the wearable, that increased the potential of collection of big data. And in particular, this includes electronic health recording data, imaging data, patients generated data through sensor, through wearable, and so on. And by mapping this healthcare data with also a geographical data set, it is possible to predict disease that could happen in a specific area. And based on this prediction, it is easier to provide the diagnostic and plan for stocking, for example, vaccines, or serum in general. So the healthcare that was a closed domain now through the big data analytics is becoming an open domain to the big data. And another example was what McDonald's does with big data, collecting them not only in an online way, but also offline. So they used For example, their app, they used the information coming from the drive-through, and they use information coming from the digital menu, no? And for example, with its own app, the McDonald's collect information about user habits, and this offer in this way tailored rewards to encourage to repeat the order and the business. But they also collecting information regarding the drive-through restaurants, allowing them to ensure that enough staff will be present to cover the demand in particular hour, in particular days. And finally, their digital menu offers different options depending on different factors, such as the time of the day, or if some event take place nearby. Think about cinema, think about also the weather. For example, if it is a not day, I'm expecting to be offered a McFlurry instead of or a cold drink in general instead of a spicy burger, no? And this is what McDonald's do, analyzing all this data coming from different data sources and also in different modality, not only online. So now, we arriving to the big data in natural disaster management. As the Professor Petri Talas said, that is the General Secretary of the World Meteorological Organization, the number of the weather, climate, and water extremes are increasing and will become more frequent and severe in many parts of the world as a result of climate change. And this is there for all to see what happens in this last day about the climate change. But this is the bad news. But what is the good news? The good news is that while the number of disasters has increased by a factor of 5, according with the World Meteorological Organization, death from disaster have decreased by a factor of 3 due to an increase in early warning and an improvement in disaster management, due in particular, I would like to add, to the analysis of the big data and how the big data can support the emergency situation. So big data technology are an important aspect to tackle the natural disaster and make the emergency response very efficient. And I'm giving you some example in the years on how the big data was used during an emergency situation or in a natural disaster management. For example, in Nairobi, an open source platform was developed in 2008, and this technology works on analyzing the area that became violent after the Kenyan presidential election. And information at a particular time came through social media and many hate witness. And the same information was put on Google Map, as you can see from this little picture, that was interactive, helping in this way the resident, to get cleared of danger. And the same technology was used also in 2010 during the Haiti earthquake, saving the life of numerous citizens who were there in the region during the emergency situation. Another example of the using of big data was what Facebook and Google developed as the application Person Finder. I think you already know this application. That and this service allow to stay connected with your family during the time of a natural disaster. And the Person Finder application developed by Google, for example, was released after the Haiti earthquake for helping people to be connected with their family member. And the platform works on the function of people entering information about the missing person and also reconnect with them at the time of the disaster. But the digital, the big data can support the natural disaster management not only during the emergency situation, but also in the pre or before that the emergency situation can happen, preparing for the emergency situation. So define the right policy by using the evidence-based approach. So, for example, citizens can share information that can be life-saving, such as, for example, the presence of family member that has a physical problem inside their house, or the decision maker can share the information about the plan and the action to be undertaken by the citizen, by the businesses, by the first responders during the emergency situation, or before the emergency situation, in order to be prepared. So big data analysis for be prepared to prepare to the emergency situation, to prepare citizens in general and people, and during the emergency situation. So the primary goal of the data analysis is to produce the insight from data that provide additional information, from data to information, and a compression to a targeted audience. And the raw data could not be an added value, as we said before. So what is important is that information coming from the raw data that bring the policy makers to take decision based on the evidence-based fact. So, first of all, what is the approach for big data analysis and storytelling, and the merging, the mix of these two important topics? So, first of all, we need to understand what is the problem in an emergency situation, no? Because we have to provide the policymaker and the citizen with information to face with the disaster. Then we need to collect the user need by using the storytelling method. And starting collecting data to create a data catalog. So this catalog is a set of open data, publicly available in order to guarantee and to foster their reuse, that can be analyzed to extract used information and to create the policy the policy in general. But the information comes from not only from the online data, but also from the organization, from data, from the co-creation activity. So we should organize some co-creation session with the people involved in the disaster, namely the first responder, the citizen, the policymaker, the businesses. And this section should involve all these actors in a round table in several activities, all the stakeholder that belongs to the policy life cycle, no? The life cycle to be built in order to create the policy. And in this co-creation section, the problems affecting the policy should be studied, discussed, and analyzed. And the knowledge coming from those sections must be, let me say, saved, and it will be part of the raw data to be analyzed among other data coming from the online source. And when we have this huge amount of data, this big data, we can go through the implementation of algorithm in order to analyze those big data. Finally, or we can reuse the data storytelling approach in order to visualize the result of the analysis through dashboard. Through them, we can tell the story narrated by the data that become information that can have a business value. And as the last step, the policy will be written down and the stakeholder we can give their feedback on how the policy work. And the cycle start again in order to improve policy based on the evidence-based fact, data-driven, in order to create, in the end, data-driven or evidence-based policy through the use of big data analysis and the data storytelling approach. To go to a citation of the former president of Italy that said, first learn, then discuss, and in the end, decide. So, but why co-creation? What is the importance of co-creation also in the data storytelling and big data analysis? So the co-creation is important because the co-creation should be the bridge between end user and technical team. If we are technical team, the most of time we don't speak the same language of the end user. So this co-creation session could be a mean to break the silos of the technician and the end user and to speak the same language, but also a mean to collect data. And talking with data, what are the properties that this data should have? They should be findable, accessible, interoperable, reusable, but what is important is their availability and usability. So in the 2016, this acronym of FAIR data appears for the first time in a scientific data journal, and the acronym was defined by, and also the principle of the FAIR data were defined by a consortium of scientists and organizations. And this FAIR data, why FAIR data? So the data must be findable. So a clear description of data must be accessible. So who can use this data? And must be interoperable. We talked at the beginning of our discussion about the interoperability. So by adopting data models and reusable. So the reusable gives value to the data by exploiting the metadata description. And the reusable is one of the most important properties of the data because they can this property gives the possibility to make business with the data. So not not having data in a silos for this specific domain or this specific application, but data should be reusable for different application in different domain. And we mentioned also the data availability and the data usability. So what is the difference and why sometimes we're talking about data availability versus data usability? So data availability refers to the accessibility and availability of data to user. And it means having data stored in a system that can be easily accessible and we can retrieve data whenever we want or we need. And this required proper infrastructure, such as storage system, network, software, in order to ensure that data is readily available. On the other hand, we have the data usability that refers on how easily data can be understood and analyzed by the user, but also by machine, no? Because for example, by using the artificial intelligence algorithms, we use data that should be understandable by the machine. And it also, the usability involves presenting data in a meaningful and user-friendly format that the machine and the user can derive insight and make informed decision based on the data. So data usability often requires also the data cleaning, the data transforming, the visualizing to make it, and this is the data storytelling, to make it more comprehensible. So these two concepts are very closely, but are distinct. And while data availability focuses on making data accessible, data usability concern with making that data useful and meaningful for the user. So data availability alone does not guarantee the effectiveness use of data if it is not presented in a meaningful and usable manner. And there is a lot of association in Europe, in particular in Europe, that dealing with data and working in order to make data available, usable, and interoperable. I'll give you some example about, for example, fireware that drives the definition of the key open standard that enable the development of interoperable smart solution. We have the data space supporting center that aims of boosting the implementation of common data space in Europe. For example, a common data space for disaster risk management doesn't exist, and we are working also, or we are thinking to build a data space relating to this domain. We have the big data value association that facilitate the data-driven digital transformation in the economy and European society, and we have the International Data Space Association that wants to provide a way for a data economy in which each individual and organization maintain the full control of data. So we are talking about the sovereignty of the data. And so starting from the data storytelling, what the Florence Nightingale made in the last century, this is the evolution of the data representation, starting from the hand made picture. We have this user-friendly and easy to use dashboard. And the data representation is the union between the data storytelling and the big data analytics. So, as the Edwards Deming said, without data, you are just another person with an opinion. No? So we need to found our decision on data. So otherwise, we are talking about our opinion. And what are the technologies in big data relating to the disaster risk management? So we have several technology. I want just to give you an overview of the technology used in the disaster risk management that collect big data. So, for example, when the disaster happen, so the first responder, the rescue, can use real-time satellite imagery to see what's is happening on the ground, and this should be done to find people that needs assistance. For example, you think about a floods when the people go to the roof tubes, for instance, or they are in the middle of the raging river. So meteorologists can use this satellite image to spot disaster as they are forming. And if they are, or if they see early sign of a tropical storm, of plumes of smoke from an active volcano, for example, they can pre-alert, send warnings to people in order to evacuate. And artificial intelligence can help make sense from this satellite image coming from space. Sorry. So using the computation and the deep learning, it can identify the areas that are vulnerable to extreme weather, recognize everything from cloud formation, for example, categorize this kind of data, so the first responder can easily follow the events in real time. For example, the Japanese government was among the first organization to recognize the utility of big data in the disaster management during the landslide happened in 2014, that create a system that use on one hand artificial intelligence, on the other hand satellite imagery, to predict imminent landslide. And another way was the drone survey, so the acquisition of the drone images. So, for example, during the Hurricane Katrina in 2005, that devastated the most part of the Louisiana and Mississippi, the first responder deployed two UAV for the first time in a natural disaster management to search for trapped survivors during along the Mississippi River, and after 2 hours that the drone go forward and back, rescue determines that there is no other trapped person. And also another important technology in big data is the social media. So during a cause of the disaster, what the responder needs is the accurate information, and the most of time we have a lack of current and accurate information, and social media might be the key to getting this information. So during the 21st International Conference on Mobile Data Management, a prototype for a system that can help to coordinate rescue operation by analyzing the tweet from people affected by the disaster was presented, and a cloud-based system that use machine learning to aggregate all these tweets in a methodical way was developed. And when this system finds a given keywords, it collects all the tweet related to these keywords. For example, tweet coming from rescue needed, disease, elderly, pregnant woman, water needed, sick floods. So the system can prioritize the rescue efforts by aggregating different factors such as weather, GPS location, the type of help needed by the people, and by extracting this data from the natural disaster management from the social media post, the tool can detect and support the first responder to better respond to emergency situation. And also, while drone and tweets can provide critical information during and after the disaster, the Internet of Things technology can provide critical information before the disaster. So, for example, the water level monitoring sensor in a spare during in the sea, for example, or in a river, can detect, can monitor the water level, and they can catch signal of flooding, no? And some sensor measure also their air quality to detect dangerous level of pollution or chemicals like smoke and radiation. So we have a lot of technology, and one of the most important technology also in big data analytics in particular, not for collecting but for storage and analyzing the data, is the cloud. So the cloud are often messengers of catastrophes, no? And satellites, drones, social media, and IoT are using cloud computing to capitalize on big data and advance the world of the disasters management. And instead of jeopardizing lives, this kind of cloud is saving lives, no? and mailing all the data captured, collected in the age can be quickly processed in the cloud. So we have, and in this way, we talk about the cloud age continuum, because we can have weak point, a strength point in the age in the cloud. So what is the weak point, for example, in the cloud? This could be the delay in transition of data. So sometimes it's better to process data on the edge and then pass the analysis or the data processed directly in the cloud. Think about collecting satellite image or collecting video from drone that could weight 1 gigabyte or a lot of gigabyte, and this should be transferred to the cloud. Maybe it's better when the capacity of the device allows the kind of processing to process the data on the edge and transfer only the processed data into the cloud, because the cloud can aggregate data and perform more computational driven analysis that requires more computational resource. And in this topic relating to the big data analysis and big data technologies and the data storytelling, maybe you already talked during this lecture today about someone mentioned the TEMA project, where we are involved, and in particular Professor Pitas with the Aristotle University of Thessaloniki is the coordinators of this project. Just to give you a brief overview of this project, where we are applying all the most of the technologies I presented, and the concept of the data storytelling and the big data analytics. So TEMA, that means trusted extremely precise mapping and prediction for emergency management, is wants to will be an AI enabled natural disaster management platform, which will be demonstrated and validated in two important pilot cases, in the forest fire domain and in the flood domain. So we will provide an advanced AR visualization that will be interactive and accessible, and it will allow human operator to understand complex natural disaster phenomena, and to evaluate them in order to propose an alternative response strategy by selection of different platform parameter and novel wave of combining heterogeneous data. And in the end, the TEMA will provide a scalable and efficient natural disaster analytic as a service platform for making the developed advanced analytics tool available over the edge cloud continuum to support decision making in order to take the relevant information to make the best possible operative decision. So, as I anticipated, we have 4 case study in Germany, Greece, Italy, and Finland. In the Central Europe, in Germany in particular, we have a case study relating to the floods. In Greek, we have a case study relating to the forest fire. In Italy, we have both the floods and the forest fire in the region of Sardinia. And in Finland, we had a pilot relating to floods in the region of Kajaani, in particular in Kajaani city. What is the concept and what is the architecture behind the DEMA concept? No, we have a lot of data coming from different data sources, so satellite image, drone image and videos, smart sensor, and social media. All these data will be processed by exploiting the modeling and prediction developed by some partners of the consortium. And this data will be analyzed in the cloud continuum environment in order to provide pilot through the interactive visualization of the information to provide the first responder with a added value response planning and recommendation. And this strategy and this platform, technical platform, but also the methodology will be tested in different cases, case study, as we said, and in 4 pilot trials. What my company, Engineering Informatica, will provide in order to support this digital transformation, in order to support the natural disaster management. We provide a platform naming the digital enabler, that is the data ecosystem platform that allow to accelerate the time to market of the time to market or in the data management in general. So what is the 4 main points? So we need to define a data catalog related to the ecosystem we want to create, and use heterogeneous data coming from different data sources by exploiting big data and artificial intelligence, take care about security, and trying to break the silos where the data is now. As I mentioned during the healthcare services, some domain, for example, healthcare or public administration, have data in the silos, and we need to break the silos to public made available this data. And we use this platform, the digital enabler, in different case study for example, in the augmented city, digital industries, smart energy and utilities. And what is the main future of this digital enabler? So this is the ecosystem platform, allows you to discover, integrate, harmonize, visualize the scattered and multi-sourced data that belongs and were scattered among the cities. So the digital enabler will represents the single access point of knowledge for a city. So we collect, with the digital enabler, you can manage all the entire big data value chain for discovering and collecting to the visualization. And this solution was exploitable in and integrated and efficient platform, providing different services for different digital ecosystem domain. So we have first the data, then the visualization. So we have big data and data storytelling for different domain. As you can see, this could be used by smart cities, smart energy, smart agriculture, and so on. And this is what is the architecture, the multi-layer architecture of the digital enabler. So starting from the bottom, we have the connection to the device and the management of the device and the management of the data collected by the device. Then we have a layer of the data integration when we can integrate data and make them interoperable through the use of the Open API on one end and for the integration and the use of the data model and metadata for the interoperability. And then we, starting from the data, we can analyze them through the artificial intelligence in order to provide this data to the upper layer, to the end user, to be visualized by the end user to provide added value information. We are connected with the edge, of course, and the platform has different actors involved, starting from the data engineering, goes to the data scientists, the application developers, the machine-to-machine IoT, and third-party software, because we can connect with third-party software to finalize the business analyst that will provide in the end the information, the added value information to the end user. Why choose the engineering digital enabler? Because the digital enabler was built following the microservices and container-based architecture that can give specific and vertical services for solution for different domains. We use only open source software, so avoiding the lock-in with vendors and technologies. We provide also a no-code or low tool suite to accelerate the development of the new apps, and we allow to easily enrich and mashup data through low-code tools, through a mashup, visual mashup editor in order to harmonize data in the standard data model. So, coming from the conclusion, so we talked about big data and data storytelling that are not new concept, but are an evolution of concept already used in the past from other scientists. But what is the difference? The difference is now we are talking about data coming from different data sources and from different domains, and what the data can tell us is an added value information and not that comes from the analysis of the raw data. So raw data at the beginning, then analyzing of this raw data to give us added value information. And why we are using big data analysis and data storytelling in the natural disaster management, because the final goal of natural disaster management is to improve the life of citizens. And and these two topics is important in different period of the emergency situation. So to be informed, to prepare, to be prepared before the emergency situation happening, during the emergency situation, and post the emergency situation when we want to analyze the damages and we want to take decision in order to restart, let me say, the life. And please After this our discussion, bear in mind from now on that in God we trust, as Edward Deming say, but all the other must bring data. Thanks a lot. I don't know if there are any question.
There are some questions in the chat as well, I believe.
So don't be shy, no problem for that. So your question allow us to find solution.
Antonio, there is a question in the chat.
In the chat? Ah, okay. Oh, this is a good question regarding an upper national system for centralized storage and dissemination, high resolution, reliable heterogeneous data. The idea of the organization I mentioned, the Big Data Value Association, Fireware, the data space, is not to create an upper national system, but to create different system, different catalog that could be that can be interoperable and can be integrable. So when I need data for a specific domain, I know that there is several data catalogs that could be interoperable and that could be not only a unique access point, but they can be distributed among the countries or in a country. And for example, in Tema, what we are doing is to build a data catalog relating to the natural disaster in order to provide the community of the data scientists also with our data catalog. And what could be interesting is that starting from this data catalog, we can build, we should build, or we can think to build a data space relating to the domain of disaster management. Thanks to you, Victor and Stamasha. Any other question? No? Thanks a lot. Thanks a lot for this opportunity. And if you have any question or you want to have additional information, you can write me to the antonio.filograna